reflection? Anyone remember? You have a reflection, you are flipping. Okay, so that's one word is a flip. So we are in lesson 6-2. Talking about reflections, and today's date is 4/18/16. So let's give a definition. Yes. Is it? Sorry. So a reflection. Highlight that. There we go. It is simply a mirror image of the original figure. If you've ever stood in front of a mirror and you put up your right hand, what it appears to be is your left hand in the mirror. Okay, so that's when they're talking about that mirror image. So it's kind of an interesting thing. Now, the key thing to a reflection is that there is an object that you're reflecting over. So a mirror, it's the physical mirror we're reflecting over. So the distance you stand from the mirror, you are actually appearing that same sort of distance away. So your body looks exactly the same in the mirror, not further away or closer up because of the distance you have to that. So that object that you are reflecting over is called a line of reflection. So line of reflection is what the object reflects over. So for a mirror, it's the mirror, and we're going to be focusing in on the couple different things. We're going to focus in on the axes in the coordinate system, and we're going to talk about maybe different points, so different lines, but they're either going to be horizontal lines or vertical lines. Go ahead. Okay. Now, what's important about this line of reflection is this equidistant idea, is that you're going to have, whatever points you have are going to be equally apart from that line of reflection. So each point, is reflected the same distance from the line of reflection but on the opposite side of it. Okay. So we need to figure out where that line of reflection is, and then we need to figure out how far our points are going to be to the right and to the left. So what I'm going to do is just give you a couple of quick examples, and then we're going to first try to figure out what did it reflect over. Okay, and that's really, and what's happening to the coordinates, okay? Okay, so I'm going to pull up my graph paper. So again, with your homework, anytime that you need to be graphing, I believe those problems come with graph paper. So you're going to do your physical graphing in your book, but then in your spiral you can write out the values that they're looking for. Okay. So basically we're going to start with, let's see, I need to go left to to -4 and up to -4. So I think we're going to go by 4s. Oh, I went way too big. So here's my x's. 2, 4, -2, -4. So 4, 2, here's my y's. -2, -4. All right, so let's start with this shape. It's going to be at -2, 1. Let's go to -4, 1. And let's go -4, 4. So I'll write out. So we have -2, 1, -4, 4, -4, 1. And I'm going to write them over here. So this is the pre-image. Let's call these A, B, C. How about that? So A is at -4, 4. B is -2, 1. And C is -4, 1. Okay, so now what I want to do is I want to take that image and I want to flip it. And my axis of, or my line of reflection is going to be the x-axis. Okay, so what I want to do is take that shape, not slide it so it stays in the same position, but I want to actually flip it. So that makes C prime is going to end up being here, 1 away from my line of reflection, because I was 1 above it in my original, my pre-image, and my image is going to be 1 below it. So that's my C prime is going to be here. So I can write, so my image, we've got C prime is at, let's see, -4, -1. And then B prime would be here. And B prime would be located at -2, -1. And then we're 1, 2, 3, 4 above on A, so we're going to be 1, 2, 3, 4, 4 below the x-axis on the image. So A prime is going to end up at -4, -4. Okay, so notice the point is at the bottom in the image where the point was at the top in the pre-image. That's where the flipping is going to take place. Okay, so look at your coordinates. Look at A to A prime, B to B prime, C to C prime. And do you see anything interesting happening to the coordinates? Dylan, what do you see? Okay, did anything happen to the x's? No. Okay, so when we reflected over the x-axis, this is what it seemed like the rule was. We started with our pre-image, but in our image, x remained the same, but we took our y's and multiplied them by a negative. So 4 in A, in the y, became a -4 for A prime. 2 for B in the pre-image on the y's became a -1 in the image. And then C, we had 1 for the pre-image's y, and we got a -1 for the C. It's a kind of a cruddy -1, but it works. So, all right, that's interesting. So let's take this drawing, let's keep it, but now let's change our point of reflection. Let's reflect our pre-image over the y-axis. So this is our job now, is we're going to reflecting over the y-axis. So what do you guys predict might happen to the coordinates this time? What do you think, Devin?
The y will stay the same and the x will turn negative.
Okay, so I'm going to write that down, and we'll see if you're right. So there's our pre-image, and he's predicting that x is going to become negative, and then y will become positive. Now, remember, it's not we get a negative x, but we take a negative of the x. Okay, so what we're going to do is count again. If you notice, B is 2 to the left of our line of reflection, so our B prime would have to be 2 to the right. So there's going to be B prime. And I'm going to write down the coordinates of the image. So I've got B prime is going to be at a 2, 1. Okay, let's look at what the image was. Negative 2, 1. So the negative of negative 2 is positive 2. 1 stayed 1. Okay, I think Devin's on to something. Let's see if it keeps working. Let's see. The C is 1, 2, 3, 4 to the left of the y-axis, so C prime would have to be 4 to the right. 1, 2, 3, 4. So that would give me C prime, and those coordinates are at 4, 1. So the image, pre-image, we had negative 4 for the x, so the negative of negative 4 is positive 4, and 1 stayed the same. This is looking good. My A was 1, 2, 3, 4 to the left of the y-axis, so my image would be 4 to the right. 1, 2, 3, 4, and that's where A prime would be. So A prime is at 4, 4. So my pre-image was at negative 4, 4, so the y stayed the same, and the negative of negative 4 is positive 4. And again, your picture flips. Okay? Good job, Devin. So he's absolutely right. That's what happened. My x's were the ones that had to change signs. Okay? So keep this in mind when you're seeing these negatives. That's not saying that's what you're going to get. This is saying you're going to get the opposite y of the pre-image. And when you're reflecting over the y-axis, you're going to get the opposite of x, or the opposite x, let's say it that way, of the pre-image. Okay? All right, that's pretty cool. All right. So let's do a couple of examples of like what you're going to be doing on homework. And have you guys ever done this? I remember doing this when I was teaching 5th grade, where you would get half of a picture and you had to create the other half, okay? Or you've done it maybe in an art class, or maybe you've like taken a mirror and you've just looked at half of your face and then tried to draw it out, and then when you look at it, it doesn't look like you at all. Because our faces, whether you think it or not, are not symmetrical at all. So when you draw this half of your face to mirror on this half, it doesn't look like you. And if you do this half and you look over there, it doesn't look like you. It's because each side is different. So that was doing reflections. Ethan, that can just go on my chair. Thanks. So let's do one example, or let's start with one example. So first one. We're going to talk about triangle ABC that has the vertices of A, which is at 5, 2, B, which is at 1, 3, and C, which is at negative 1, 1. And we're going to graph this figure then reflect it over the x-axis. and then find the coordinates of the reflection. Now, they may call it the reflected image, they may call it the image, okay? So let's see, I need to go 5, 3, okay. Let's do this up here. So we have X, we have Y, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. So negative 4, negative 2, negative, or 2, 4, negative 2, negative 4, 2, 4. So we're going to graph the pre-image, which is at 5, 2, that's our A. B's at 1, 3, and C is at negative 1, 1. Okay, so that's our triangle. And we want to reflect over the x-axis. So, let's see how well we're going to do on this. What's going to stay the same in the coordinates? What do we just write down would stay the same? No ideas? All right, well, let's just figure out how far things are and we'll just move. So A is 2 above the x-axis, so its reflection would be 2 below the x-axis. So that's your A prime. So that's at 5, negative 2. All right, so look at your pre-image. A was at 5, 2. A prime, the image, was at 5, negative 2. So what stayed the same? The x stayed the same. So when I reflect over the x-axis, the x stayed the same. Okay, what happened to the y value though? It became negative. So we had an opposite sign. All right. B, it's 1, 2, 3 above the x-axis, so it's going to be 1, 2, 3 below. So there's your B prime, and the coordinates are 1, negative 3. Did the same thing happen where x stayed the same but y's changed signs? We had 1, 3. We are at 1, negative 3. Okay, we're not playing today. I know it's Monday. Let's see, C was 1 above the x-axis, so the image would be 1 below the x-axis. So there's my C prime. So we're going to write the coordinates are at negative 1, negative 1. So what I notice from my pre-image to image, x stayed x, but my y numbers changed signs. Okay, and notice that the peak at B was the lowest point. So that's your flipping that's taking place of your shape. Okay? All right. Let's do one more. Just like this, but let's do with 4 points. Everybody good here? Okay. So notice if you don't understand a pattern, that's fine. All you have to do is count. That's all it takes for this one. So this one we have a quadrilateral. Which just means 4-sided figure. And it is called KLMN. And it has vertices. K, which is at 2, 3. L, which is at 5, 1. M, which is at 4, negative 2. And N, which is at 1, negative 1. So you're going to graph KLMN and its reflection. But this time we're going to go over the y-axis. And then find the coordinates. So same idea, but we're going to go over a different axis, and we have a slightly larger shape of the reflection, or the reflected image. So this would be another homework assignment where I would be using maybe 2 different colored pencils. That would help me distinguish my pre-image from my image. So let's see what I need to do. I need to go 5, 4, 2, negative, looks like this, 1, 2, 3, 4, 5. So here's negative 4, negative 2, 2, 4, and then we went up 1, 2, 3, 4. My y's. So let's make KLMN. So we're at 2, 3 is the pre-image K, pre-image L is at 5, 1, pre-image M is at 4, negative 2, and pre-image N is at 1, negative 1. So we connect those up. Okay, looks like it might be a trapezoid. And then we're going to reflect it over the y-axis. So we're going to create K prime, L prime, M prime, N prime. Any thoughts on what's going to happen to our coordinates on this one? Dylan, you got a thought? Okay, so the y's become negative, and the x's stay the same?
Oh, no, the x's go negative.
Okay, so x's go negative and the y's stay the same? Or does something happen to the y's as well? Well, let's try it out. Remember, all we have to do is count. K is 2 to the right of the axis, their line of reflection, so K prime would be 2 to the left. The coordinates are negative 2, 3. So compared to the original, it was 2, 3. So it looked like y didn't change, but it looked like x's changed. Okay? Let's see, L is 1, 2, 3, 4, 5 to the right of the axis of symmetry, or not axis of symmetry, sorry, the line of reflection. So L prime would be 5 to the left. So 1, 2, 3, 4, 5. So there's our L prime. And its coordinates are negative 5, 1. So compared to L was at 5, 1. So same thing. The y's didn't change, but the x's did. M, let's see, M is 1, 2, 3, 4 to the right. So M prime would be 4 to the left. 1, 2, 3, 4. So there's my M prime. Its coordinates are at negative 4, negative 2. We were at 4, negative 2, so the negative 2's, the y stayed the same when I did the reflection, but the x's changed signs. And then N, let's see, N is 1 to the right of the line of reflection, so N prime would be 1 to the left. And we end up with the coordinates negative 1, negative 1. And that's, again, same thing. Y's didn't change, but the x's changed signs. So again, not only are we're keeping exactly the same distance from that line of reflection. So that's part of what you guys are going to do, and then your job would be to put in, they have an example, I'm not going to do it because it's just too pretty for me to draw. They want you to take a drawing where they give you half, and then they want you to reflect it over an axis to see if you can create the full picture. Okay. I'm not exactly sure how you could recreate a frog with 2 points, but that's what they're doing. I see in the book on the example 3, which is kind of fun. So that's what you guys get to do tonight on pages 465, 467, 1 through 6, 8, 13 to 19.